Now it's time for Jonas Christensson, who is an acoustic consultant working with Ecophone. And Jonas is a specialist in room acoustics, and not only room acoustics, but the room acoustics usually land you up into the woods for some reason or another. And
for some reason, yes.
About that, I think.
Thank you. My name is Jonas Christensson. I work as a concept developer for Saint-Gobain Ecophone in Sweden. And I spend a lot of time studying how sound in schools affect people. And my presentation will be about two boys, and I will also have a small sound quiz in my presentation. This is the first boy I'm going to talk about. His name is Albin. He is my son, and this is a picture when Albin went to preschool. Here we have Albin in primary school, in middle school, in secondary school, and in upper secondary school. And over all these years, when he have worked in school, he have been working in different buildings, the preschool, the primary school, secondary school, upper secondary school, and right now he is studying at a very nice university located here in Lund, actually. And since Albin started at preschool, I have investigated the sound environment in all the buildings that he have been working in. And I have asked teachers and also some students about what they think about their sound environment. And very few people think about it until I raise the question. And then we have a reaction, especially from the teachers, saying that we have problems with high sound levels, which makes it hard for me to teach. And my job is to find solutions of the problem, and we find the solution here at the savannah in Eastern Africa. That's where we started to develop our hearing when we were monkeys. So we can say that our hearing is quite old, and from the monkey stadium we have developed. It's up to you to decide in what direction. But the interesting thing is, over all these years, we have spent the major time outdoors, and that's why our hearing works best outdoors. This room is quite okay, but it would have been better if you had been sitting in the forest listening to me speaking, because in the forest your hearing works so good. The problem is that most of the teaching in Sweden takes place indoors. And when the teacher is talking in a room, the voice is propagating throughout the room, and then it's important that the students can hear what the teacher says. It's also important to hear where the teacher are when he's speaking. These two things is important for the children to feel safe from the acoustical point of view. And if you feel safe, it's easier to learn. And if you don't feel safe, it's hard to learn, and that's not good for the students nor the teachers. So the acoustics really affects learning, and it also affects teaching, because it affects the way the teacher is talking, as Vivica talked about. Some part of teaching is about talking and listening, and that's why it's so important that the room fully support these activities. When I'm standing here talking, sound waves are propagating from my mouth into the room, and then you sit in the room with your ears, and the sound waves is hitting your outer ear, which is a marvelous construction to gather all these sound waves and lead them into the ear canal. In the end of the ear canal, we have the eardrum that starts to vibrate. We have a small bone chain helping the vibration into the inner ear, and in the inner ear it's converted to electricity that via the auditory nerve goes up to your brain, and then you can hear. It's a wonderful system. You hear my voice and all the reflections from this room, and this is what I'm working with, creating right type of reflections to support speech intelligibility. If we look at sound environment in schools, it's not so good. There is a lot of investigations showing how bad it is with the sound environment. But we have asked instead for the acoustic requirements what teachers and students want to have. And they want to have lower sound levels, better speech intelligibility, and better speak comfort. In Sweden, we start quite early in preschool, and we end up very often at the university. In the preschool, we need lower sound levels, that we have heard before, and in the university, the students want to have good speech intelligibility, and the speaker want to have good speak comfort. The time between preschool and university is called primary and secondary school, and there we have a lot of different room types. We have corridors, canteens, and sport halls, and we also have the teaching room where we have both traditional teaching and group work. If we ask for the acoustic requirement in these three room types, it's a very clear answer. They want to have lower sound levels. Very few say that it's too quiet in the canteen, so to say. If we look for the acoustic requirement in the teaching room, first of all, they want to have lower sound levels, and the teacher want to have good speak comfort. The students want to have good speech intelligibility, and when we have group work, we want to hear the group members, but not other groups. And the most complicated thing to create is speech intelligibility, and it's affected by three factors. First of all, the voice of the speaker, and then we have the listener's hearing, and the third part is the room acoustics. And what room acoustics should do in a classroom is to make it easy to listen. If you can listen without effort, it's much easier to learn. And when it comes to room acoustics, I had a wonderful experience for about 5 years ago when I was in the forest, again with Albin. Now he's that old. Then I discovered that he could hear what I said at very long distances, even though that I deliberately spoke with a low voice level. So the speech intelligibility in the forest is extremely good. So I got curious. I took a loudspeaker, a MP3 player, and a sound level meter. I went into the forest. I connected my MP3 player, and then I could listen to this.
Det var en måndag på förvåren. I matsalen på gamla hotell Horn i Malmö dukades det allmänna smörgåsbordet till supén.
It's Hans Alfredsson reading a wonderful audiobook written by Fritjof Nilsson Piraten. And then I controlled that the sound level 1 meter in front of the loudspeaker was 60 decibel. That's the normal speech level when you talk to a person at a distance of 3-4 meters. And then I sat down and listened to this book, and I moved myself further and further and further away. I ended up 20 meters away from the loudspeaker, and I could very easily hear everything that Hans Alfredsson was reading. When I was sitting there in the forest, I was listening to the sound waves propagating from the loudspeaker, but I was also listening to the reflections from the forest, and then I got curious about what kind of reflections do we have in the forest. So I have done a lot of measurement in different forests, and I've been using an omnidirectional loudspeaker and a microphone, and then I've sent out the sound waves into the forest, and I have recorded the sound reflections. And when you look at that, you have decibel on the y-axis and you have time on the x-axis. And when you go out in a forest, the summer day, the level is around 30-35 dB, and then you send out the signal, and from this part of the decay, you can evaluate the forest reflections. In Sweden, we have building regulations, and we put requirement on the classroom acoustics, and the requirement is put on something that we call reverberation time, which is the time it takes for the sound pressure level to drop 60 decibels. So this is what we are measuring, a certain time. And when you show that, you have the time on the y-axis in seconds, and on the x-axis you have the different frequencies. And I've done a lot of measurement in different forests, and I can see a pattern in the result, and it looks like this. We have a lot of reflections in the forest in the higher frequencies, and that is really reflections from the tree trunks. If I compare that to the result in classrooms, it looks like this. And then we can see that in the higher frequencies it's almost the same, but in the lower frequencies there's a difference. And especially at 125 Hertz there's a big difference. And these reflections create poor speech intelligibility. And then it's hard to learn, and that's not what we wanted when we built this classroom. Speech intelligibility it describes the ability of the possibility to hear the speaker. And then we can look at hearing. On the y-axis we have decibel, and on the x-axis we have frequency. This is what we can hear. This is the hearing capacity of a teenager who never had an MP3 player, so it's not so common. But the interesting thing is that right in the middle of the hearing capacity, there we have speech. And when I'm talking to you, I'm using vowels and consonants, and they are on different places on this chart. Here we have the vowels, here we have the voiced consonants, and here we have the unvoiced consonants. If I say A and close my mouth, it will be an M. A and M have the same frequency, but A is stronger than M. If we measure a voice with a decibel on the y-axis and frequency on the x-axis, it looks like this. This is what we call the speech spectra. And if we look at the speech spectra, we can see that here we have most of the vowels, and here we have most of the consonants. The vowels are low in frequency and strong in strength. The consonants are low in strength and high in frequency. So vowels are stronger, but it is the consonants that carry information in most languages. We can make a test. I will give you 2 sentences with my vowels. And I don't think it's so easy to see what I'm trying to say. I gave you the consonants instead. I think most of you can understand what I'm trying to say, even though that English is not your native language. So the consonants carry information, then the room acoustics should really support the consonants. And how do we do that? Well, actually by absorbing the vowels. And we can explain that by talking about water in old basins. We had in old basins hot water and cold water, and you turn on the hot water and the cold water, and then you took the plug into the button, and then you get a certain level of water, and the temperature was medium or lukewarm, as we say. If I want to have colder water, how do I do then? I can't add more cold water. So what I need to do is to reduce the warm water. Then it's colder, and that's what I wanted. If we now think that the basin is a classroom, we have hot water and cold water, or warm water, and warm water can stand for vowels, cold water can stand for consonants. If I want to increase the speech intelligibility in the classroom or the basin, I need more consonants, and the way to get more consonants is to reduce the vowels. If I do that, then I create good speech intelligibility. If we look at the classroom reflections in Swedish classrooms, we can see that we have a lot of reflections in the low frequencies where we really support the vowels, and that's not so useful when it comes to speech intelligibility. So we do acoustic treatment, and what we do is often this. We absorb the high frequencies, and people react like this directly, because what we do, we absorb the consonants and let the vowels stay in the room. So the right treatment in classrooms is to reduce the low frequencies. If we do that, both teachers and students react like this, because then we create the same reflections as we have in the forest. And to create the forest acoustics in a classroom, there are 3 things we need to think about. First of all, we need a silent ventilation system, because this is the biggest problem in classrooms. Because when you go out in the forest, you are not listening to any low frequency sounds from ventilation system. You are listening to bird songs and wind from trees. The second one is to create the acoustic sky, as I say, because in the forest you never have any reflections at all from above. And the third part is to avoid hard, flat, parallel surfaces, because that's how the situation is in the forest. We have a lot of reflections, but they are not hard, they are not flat and parallel. So we have a lot of reflections from trees that are convex in shape. I said I should have a small sound quiz as well. Sometimes I have a competition with the audience where I ask them, do you remember the sound? And I will start with the sound number 1, which is a sound from a movie. Somebody takes it quite easy. Yeah, you know. It's the shark or Jaws. Sound number 2, it's an animal. Not so easy. It's an otter, an angry otter. Sound number 3. Any guesses? Actually, most people think it's an old boat engine, but it's not. This is a sound system for parents who want to give their child a head start in life. According to the company who produces this system, they say learning begins here. So they have produced a sound system that you should put on the stomach, and you should do it quite early. After 18 weeks of pregnancy, you should start with this. And they have different sessions. And this is session number 1. The session lasts for 1 hour, and the company's recommendation is that you should have 2 hours a day. This is session number 4. It's a little bit more complex. And what you thought was a boat is not a boat. It's session number 8, according to this. This is the last session they have. So the question is, the price for this is $180. If I add an extra 5, I get also a CD with Mozart music for mothers-to-be. And I've been thinking about buying one, but now I've learned from you before that it's much easier that I sing myself and talk myself. I think it's worth the money, so to say. So far, I've only talked about one boy, but I said I should talk about 2. This is Albin. I've talked a lot about him. But a couple of weeks ago, I went to North Sweden to a preschool, and I did some sound measurements. And there was a guy coming running to me, and he said, "Hello, what's your name? How old are you?" "I am 3.5. What do you work with?" "I have a cat. Do you have a cat? Do you know where my mother works?" You know, all these wonderful questions that you get from these children. And I explained to him what I was doing, measuring sound, and sound is important, and he was listening very carefully. And then he walked 60 centimeters behind me the whole day, asking questions. And I did this measurement over 2 days, and the next morning he came to me with his iPad, and then he said, "Now I know what you're doing and what you're working with, because you're like the trolls." And then he showed me a film of the trolls. And he explained to me that trolls are very nice, but they were threatened by the monsters, so they had to escape, and they walked through tunnels, and finally they found a place where they wanted to settle down. And the king of the trolls held a speech. And I think it's quite wonderful that if a 3.5-year-old boy can understand the value of sweet acoustics, we can only hope that he will be an architect and design schools in the future. So, thank you.